In this video, I'll be solving the sixth problem of JEE Advanced 2025 Maths Paper 1. So, we were given two functions f and g, where f is from natural numbers to integers and g is a one-on-one mapping from integers to natural numbers. And like we were given f of n is n plus 1 by 2 if n is odd, and f of n is 4 minus n by 2 if n is even, and g of n is 3 plus 2n if n is greater than or equal to 0, and minus 2n if n is less than 0. And like we're having g of f of n and f of g of n, and we are asked about their nature. So if we consider like f of n, so f of n is n plus 1 by 2 and 4 minus n by 2. So that is, if n is odd, it is n plus 1 by 2, and if n is even, it is 4 minus n by 2. So for every odd number, so if we are having f of 2k plus 1, so then it will be 2k plus 1 by 2. And if we are having f of 2k, it will be 4 minus 2k by 2. So that means it is k plus 1 for odd numbers. For f of 2k plus 1, it is k plus 1. And f of 2k, it is 2 minus k. So that implies, like for example, f of 1 is 1 because it is 2 into 0 plus 1. So it will just be 0 plus 1. And f of 2 will be like 2 minus 1, which is again 1. So we can clearly see that f is not 1, 1 from this. And similarly, f of 0 is 2, and even f of 3 will be 2. It's in that way. Now, if we consider like f of 1, so f of 1 is 1, and we are getting f of 2 is 1. And f of 3 will be 2, f of 5 will be 3, f of 7 will be 4, and so on. And similarly here, f of 4 will be 2 minus 2, which is 0. And f of 6 will be 2 minus 3, which is minus 1. F of 8 will be minus 2, and so on. So that means like it is spanning like all the integers from minus infinity to infinity. So that means f is not 1, 1. That means f is many 1, but f is onto. So that's the nature of f of x. So if we consider the fourth option, they are saying f is not 1, 1, which is correct, but f is onto. Yes, the statement is correct. Now, if we consider g, so g is so g of n is 3 plus 2n and minus 2n. So this is when n is greater than or equal to 0, and this is when n is less than 0. So g is spanning from g is from integers to natural numbers. So if we consider g of 0, g of 0 is 3, g of 1 is 5, g of 2 is 7, g of 3 is 9, and like g of minus 1 is 2, g of minus 2 is 4. So we can clearly see, g is 1, 1, because like we can see it's an increasing, like as we increase the n value, the values are increasing, and even like when we decrease the n value, the values are increasing, like for negative numbers. So we can clearly see g is 1, 1. But like we can see on the other hand that g is not onto. Why? Because like we won't be getting 1 at any point of time. Like g of n is not equals to 1 for any n belongs to integers. So g of n can't be 1 for any of those integers. So that means like we're not having one element from the range. So that means from the codomain. So in order for a function to become an onto function, so its range should be equal to codomain. So g of n like can't be 1, but 1 is in the codomain here. So that's why like z is 1 1 but not onto. So if we consider, they are saying g is 1 1 and g is onto, so that is wrong. Now in the similar way, so now like it's about composition, so we need to work it out for g of f and f of g because it's a multi-correct choice. So let's take like f of n. So f of n is n plus 1 by 2 and 4 minus n by 2. So this is when n is odd and this is when n is even. And similarly g of n is 3 plus 2n if n is greater than or equal to 0 and minus 2n if n is less than 0. So f of g of n will be g of n plus 1 by 2 if g of n is odd, and 4 minus g of n by 2 if g of n is even. So that means, and g of n is like 3 plus 2n if n is greater than or equal to 0 and minus 2n if n is less than 0. So basically 3 plus 2n is odd, so g of n is 3 plus 2n or 3 minus 2n it can be. So basically g of 2, so 3 plus 2n is odd when n is greater than or equal to 0, or 3 plus 2n is even when n is greater than or equal to 0, or like minus 2n is odd when n is less than 0, or minus 2n is even if n is less than 0. So basically I'm trying to work out everything by substituting g of n values. So basically this case is not possible because 3 plus 2n can't be even at any point of time, and minus 2n also can't be odd at any point of time. So basically we're having only these two as possible cases. So that means it is g of n is 3 plus 2n in this case, so 3 plus 2n plus 1 by 2 in the first case, and in the last case it will be 4 minus of minus 2n by 2. So that means f of g of n will be 4 plus 2n by 2 if n is greater than or equal to 0, or 4 plus 2n by 2 if n is less than 0. So that means it is just n plus 2 if like for all integers, for all n belongs to integers. So that means like f of g of n is n plus 2 for all integers because g take all integers. So here like if we try to understand the mapping, so f of g of n, so if we consider like f of g will have mapping from integer to integers. So that means like f of g of n, like we can clearly see it is 1 1 because it's increasing for different values. I mean, as we increase the values, the function is increasing, so it's a monotonic function. So that's the reason why it will also be 1 1 function. And f of g of n is also onto function because whatever the integer that you need, like minus 5, suppose if you need minus 5, you take n is equals to minus 7, or if you want like n is 7, you can take n is equals to 5. So whatever the value, whatever the integer it is, like it spans the entire integers, that n plus 2. So that is the reason why f of g of n is also onto. So f of g of x, f of g of n is not 1 1 but onto, but like we have seen that it is both 1 1 and onto. So option B is incorrect. Now let's work out for g of f. So g of x is, so g of n is 3 plus 2n if n is greater than or equal to 0, and minus 2n if n is less than 0. And f of n is n plus 1 by 2 if n is odd, and 4 minus n by 2 if n is even. And like g is from integers to natural numbers, and f is from natural numbers to integers. So now like if we try to find like what is g of f of n, so that is like 3 plus 2 f of n if f of n is greater than or equal to 0, and minus 2 f of n if f of n is less than 0. So that means it is 3 plus, so f of n, it is 2 times of n plus 1 by 2 if n is odd, and n plus 1 by 2 is greater than or equal to 0, because f of n here, like we substitute it as n plus 1 by 2. So 3 plus 2 times 4 minus n by 2 if n is even, and 4 minus n by 2 greater than or equal to 0, and minus 2 times n plus 1 by 2 if n is odd, and n plus 1 by 2 is less than 0, and similarly 4 minus n by 2 less than 0 if n is even, and minus 2 times 4 minus n by 2. So if we consider this thing, so this is nothing but n plus 4 if n is odd, and n is greater than or equal to minus 1, and 7 minus n if n is even, and n is less than or equal to 4, and minus of n plus 1 if n is odd, and n is less than minus 1, and n minus 4 if n is even, and n is greater than 4. So now, like, if we consider again, like, G is from integers to natural numbers, F is from natural numbers to integers. So that means G of F. So F's input is natural numbers, and G's input is integers. So F's output is also integers. So basically G's input will be F's output, so which is nothing but integers, but ultimately the output will be natural numbers. So G of F will be from natural numbers to natural numbers. So that means, and so if we consider F here, F is from natural numbers to integers. So that means essentially n is odd and n is even. That means they're only considering the positive odd numbers and positive even numbers. So basically n is odd and n is less than minus 1. This doesn't make any sense. So that means our function is just like n plus 4 if n is odd. Obviously n is greater than or equal to minus 1. That means we're only considering the positive natural numbers. Obviously the natural numbers are positive. And 7 minus n if n is less than or equal to 4 and n is even. So what are the even numbers less than or equal to 4? They're just 2, 4, because like our domain is just natural numbers. And it is n minus 4 if n is even, and n is greater than 4, so basically n is greater than or equal to 6. So now, so again, like, the reason for this negative things not happening, because like we were essentially given f is from natural numbers to integers, and f of n is n plus 1 by 2 if n is odd, and 4 minus n by 2 if n is even. So that means this n odd and n even, this refers to only positive integers. So that is the reason why this third case is not possible, and even in the first case it should be strictly positive, and third case, like, anyways, fourth case we're anyways having a positive. So this is our G of f of n. Now G of so let's consider two values, like, so we are having, like, for n is odd we are having n plus 4, and for n is 2, 4 we are having 7 minus n. Suppose, like, if we find the value of G of f of 2, so G of f of 2 is nothing but 7 minus 2, which is 5. And similarly G of f of 1, so 1 being odd number, G of f of 1 will be 1 plus 4, which is also 5. So that means for two different values in the domain we are getting the same value. That means G of f of n is many 1. That means it's not 1 1. Now if we have to check, like, whether it is onto or into, we can go through one value. We can look for a counter example. Like, for example, if we consider like G of f of n, I don't think, like, this will be 1 at any point of time, because, like, for n odd, like, it is always greater than 4, and for n even, like, it will become odd number, but it it will the least it will become as 3. In this case the least is 3. In this case the least itself is 5, and in this case the least is 2. So that means like we are not reaching 1 at any point of time. So that means it is into. So g of f of n is not 1 1 and not onto. So that's the nature of g of f of n. So if we see the options, so it is not 1 1, not 1. So the correct answer will be A and D. So that's it for this video. We'll meet in the next video.